Yeah, well, we could do like
The more you know.
I think I knew more freshman year.
The more you know, you don't know.
equations with variables.
So here are some rules. If you take the derivative of e to the x, you get e to the x. Remember my e poem. When taking the derivative, it's really quite inquisitive. The exponential is its own slope. If the derivative, the slope of this curve is the y value of the curve as well. If you take the derivative of e to the u, of course you use the chain rule. It's du dx times e to the u. So the derivative of an exponential is an exponential. And you have to multiply by the derivative of the power. If you have an exponential a to the u, that's like, I'm sorry, a to the x. That's like 2 to the x, for example. Its derivative is, is a to the x times the natural log of a. Now, this could be the same. The derivative of e to the x is e to the x times the natural log of e, but the natural log of e is 1. The natural log of e is 1. Log base e of e equals 1. 1 is the power you put on e to get e. Now, y is a to the u, its derivative is a to the u times the natural log of a times du dx. Derivative of natural log of x. The derivative is 1 over x. The derivative of the natural log of x is 1 over x. If y is the natural log of u, the derivative is u prime over u. If we have the natural log of x squared, the derivative is 2x over x squared. And you reduce it. If you've got log base a of x, you would rewrite it using the change of base formula. You would rewrite it, and you'd rewrite it as the natural log of x over the natural log of a, which is 1 over the natural log of a, just the constant, times the natural log of x. Okay? And then you take the derivative. It's the constant times the derivative of the natural log of x, which is 1 over x. Okay? That's a lie. If we we have y equals log base a of u. You would rewrite it. Natural log of u with the natural log of a, which is 1 over the natural log of a times the natural log of u. Its derivative is this constant 1 over the natural log of a times the derivative of the natural log of u, which is u prime over u. Okay? That's a lot of stuff. This is the natural log. ln, natural log. Okay, any questions?
So we have to have all this memorized for the test.
So the derivative of an exponential is the exponential. Right? If it's e to the u, it's just d dx times e d. Exponential times the derivative of that power. If it's an exponential with not e, right? 3 to the x. The derivative is 3 to the x times natural log of a. Natural log of the base of the exponential. And if it's a function, it's the same thing, times, you have to use a chain rule, so it's d dx. Derivative of the natural log of something is u prime over u. That's a simple thing. This craziness, it's not so bad if it's written as a log based something, right? You just rewrite it as using the change of base formula. Natural log of this over the natural log of that. And then you pull away the constant part. The natural log of a is just some number. So 1 over the natural log of a is just some number times the natural log of x. And then the derivative of the natural log of x is 1 over x. Not much change. Let's see it in action. This is the derivative of an exponential. It is what, take the derivative, you get the same thing, times the derivative of what's inside. It's not that much to know. I'm calling on somebody.
Got it, bro.
1 out of 10.
I can do this.
I got this. I got this.
There's a 2 in 9 chance it's a Jacob.
There's a 2.
What is it?
Person who's called gets to choose a number between 1 and 10. Or they can just answer.
Oh, I'm just answering it, bro. Good thing. Pick a number.
Pick a number, please.
Pick a number.
Derivative.
I'm trying to do this.
Do it.
Done. Now it distributes, like you could write that as e to the x plus x squared plus 2x, that's on x, 2x e to the x plus x squared. This distributes into the parentheses there. If you want to write it that way, you don't have to.
Okay.
The top one's a good answer though too.
Yeah, top one's fine.
Okay.
Give it to me, Mr. Bush.
The derivative of a to the u, like 2 to the x squared. Is 2 to the x squared, to the u, natural log of 2, natural log of a, u dx times 2x.
Okay.
Okay? Let's what time is this function? Y equals 2 to the t minus 3. At what point on the graph does the tangent line have a slope of 21?
I don't got this.
I don't know this one.
It's the easiest one of the day.
What?
Pick a number.
No,
Pick a number.
so we're taking the derivative, right? So it's a derivative of 2 to the t minus 3.
Two.
Stephanie.
He can answer it if he wants.
T.
No, he cannot. You can. What's the derivative of 2 to the t? It's an exponential, so the derivative is itself. That's simple. What is it? 2 to the t. 2 to the t times the natural log of 2. That's it. That's the derivative. That's not that much to know. And we want to know at what point in the graph does the tangent line have a slope of 21? Yeah, so we put 21. This is okay. So 2 to the t is this weird number. How do I solve for t? We said log base 2, both sides of the equal sign. Log base 2. T equals log base 2 of 21 over natural log of 2. Okay. Okay, good. It's a great answer. That's the answer. You guys see anything about this log that's kind of fun that maybe would be great to check out? Like the log of a quotient. Anybody? Hello, you see this log of a quotient?
Hopefully this is what you got.
Nobody? Can we write it like this? Log base 2 minus log base 2 of 2. Oh, no, it's log base 2 minus log of 2. Yeah, that's nothing special. I was excited if it were log base 2 of 2, but it's not. Log base 2. Alright, that's the answer. That's fine. I'm glad nobody saw anything special about it. Because there was nothing special about it. Okay. What is this? The derivative of the natural log of u. 1 over u times u dx. In other words, u prime over u. equation is tangent to this curve. Don't throw too much. And sure, that's it right there. Tangent to this curve. Right here. The equation for this line is y equals mx. I m. And there's a way to do it, and I never can remember how. It does show up on the AP exam. I don't know, I've never taken the AP exam. It does show up in the practice ones. I think the deal is, the slopes have to be equal, so m has to equal 1 over x. Because y prime is 1 over x, and y prime, and y prime is m. So m equals 1 over x. And that's all I know. Typically, you set derivatives equal to each other, and I did. Oh, let's do this one, this will be fun.
Excuse me.
Yo,
Like in the last stage,
yeah,
wasn't like if m is 1 over x, isn't y just 1? Because if you put m,
y is 1. I don't know.
because like if you put m in is 1 over x times x.
So y is 1 over x times x, y is 1. So if y is 1, x is e. So the slope is 1 over e. Stephanie? That could be right. Is that what the book says? I love it. Yeah, go ahead. Since y equals m, which is 1 over x times x, y is 1. So we can take that 1 equals the natural log of x and solve for x. So we use exponential both sides of the given sign, x equals e. And that is,
But we didn't find the value now.
what is the value of n?
Oh, okay. So it's 1 over e.
And this is 1 over e. Yay, thank you. Exactly right. Maybe next year I'll remember. Oh, logarithmic differentiation. This is a thing. Because logs have great properties that dismantle things. So if you're trying to take the derivative of x to the x, like you can't use the power rule where you're subtracting 1 and multiplying, because it's a function. This is like a function to a power of a function. What you would do is take the natural log of both sides of the given sign. And then use the rules of logs to simplify this, to expand it, and then take the derivative implicitly and solve for y prime. Okay? What can I do with this power?
Put it in front.
Put it in front. So now, natural log y equals x times natural log x. Now that we have this in this form, we can take the derivative. So, the derivative of y, natural log y is y prime over y. What's the derivative of x natural log of x?
1
X times. First times derivative.
1 over x.
The first times the derivative of the second, plus the second times the derivative of the first. So, y prime over y is 1 plus the natural log of x. And then we'll solve for y prime, because that's what we're looking for. Y prime is y times 1 plus the natural log of x. Y is x dx. That's the answer. Logarithmic differentiation. I know it's a long word, but it really is a nice thing. I don't think I'm going to go on with this right now. All right, let's take a look at the homework. So the assignment I'm giving you. Three through 42 by 3s, 50, 60, 62, 180. All right, what about 3? What's the derivative?
E to the negative x times negative 1.
Negative x.
I got
6.
e to that.
E to the negative x
E to the negative x over 4 times.
times
Negative.
Say it.
Negative 1/4.
1/4.
Shoot, I was about to say that, bro.
That's what I was about to say too, bro.
You were not.
I knew
You
it
were.
You were not.
No, no.
Bro.
Come on here.
9.
E to the
Power, e to the
power
thing of x, yeah.
square root of x.
There you go, that's what I was getting
Times
square root of 1.
times 1/2 x times
We're taking the derivative of this power. X to the half.
1/2 x to the negative 1/2.
So the derivative of that is 1/2 x to the negative 1/2,
Good try.
which is 1 over 2 squared x.
Okay.
Right?
Mm-hmm.
Yeah.
Yep.
I knew it.
12.
12, 9 times
Negative
negative x. Hey, come on.
times negative.
Natural log 2. Or your
Natural log of 9 times negative 1.
Can you explain that real quick?
Well, since this isn't e to a power of something, this is 9 to the power of something, it's exponential. So its derivative is itself.
Okay.
But then you have to multiply by the natural log of the base. And if it were at e, if e were the base, we could multiply by the natural log of e. But the natural log of e is 1, it wouldn't do anything.
Oh,
Oh,
so
okay.
That's why 9
natural log of the base
does do
times
something.
natural log of the base times the derivative of the exponent.
Yes.
Okay.
Okay, I got you.
So 3 is like, or 13 is like 3 to the power of cosecant x times
Natural log of-
log 3 times
Natural
the
log of
negative
3.
sine of x.
The derivative of cosecant x is negative cosecant x over tangent x.
Oh, yeah, cosecant, sorry. So, okay, yeah, I got it.
Yep.
Alright.
15. Different rule already. U prime over u.
X squared.
Yes.
U
Oh,
prime
wait, u prime
2x.
is 2x
over u.
over
X squared.
x squared.
2 over x. Got it?
Mm-hmm.
Yeah.
18. Rewrite this, natural log 10 times x to the negative 1.
Then divide
Negative 10
So negative 10.
divided by
Oh wait.
10x to the negative 1.
U prime over u.
Negative 10 times. Wait, negative 10x to the negative 2.
Oh yeah, I forgot about that part. Negative 10x divided by negative 2. Or
To
the power of
negative
negative
2. Over
negative 10x, or 10x.
u prime over u
Just
is
10x.
just 10x times it.
Negative 1.
So you
Nate, come on, you can be helping.
Be part of our group. Let's go.
How's that simplify?
Contribute something. Let's go.
it. Just 1 over 2.
Is it just negative 1?
Negative 1x to the negative first.
Negative
What'd you
1.
say?
Negative 1 over x.
over. Oh,
Because you can cancel.
The x squared goes down, x goes up, so it's x.
Okay, yeah, I got you.
This is x.
I got you.
So, not so bad, right?
Kind of terrible, actually.
21. You rewrite it.
We read it as.
Natural log of x squared. Over the natural log of 4. So move that one to the natural log of 4 out front, and you just say the derivative of the natural log of x squared.
So it's 1 over. 1 over natural log of 4.
Derivative of the natural log of x squared.
2x
2x.
2x over x
squared.
squared. Which goes down to 2x.
So 2 over x. That is 2 over x natural log of 4.
Okay. I got you. It's just not figuring out all of this. Okay, so 1 base 2. 2x to the negative 1. Let's do natural
Oops.
of x. Natural log of x over the natural log of 2.
No,
Or negative.
negative 1
Negative 1.
times log base 2 of x to negative 2. Negative 1 log base 2 of x to the negative 2.
Oh, yeah.
Derivative of what's inside.
Times natural log of x over the natural log of 2.
1 over natural log of 2. Natural log of x. What's the derivative of that?
Of don't rewrite
You
it,
got
it's just- don't rewrite it. Okay, yeah, I got it.
What's the derivative of that?
It's 1 over natural log of 2. Or is it just x over 2?
The derivative of the natural log of x is 1 over x.
It's 1 over natural log of 2
Times 1 over x.
Times x.
Or times x.
It's 1 over x times 1 over the natural log of 2. 1 over x times 1 over the natural log of 2. 1 over x natural log of 2. What the heck is that? That is negative 1 on the top. On the bottom is
On base 2.
x natural log of 2 times 1 base 2 of x squared. But fun. What do you think?
It's alright.
It's not terrible. There are different rules. You need to know
You just
three
need
rules.
it, like, it's just remembering the rules. I feel like it's.
Three
Once we
rules.
do that, yeah.
Derivative of an exponential is the exponential times the natural log of the base times the derivative of the power. Derivative of a natural log of something is u prime over u. Derivative of a log base something, right? Log base. You rewrite it and then take the derivative of natural log of u. So, 27. It's a log, so you can move this x to the front. 27 is the easiest one all day. Alright, tell me what I can do with these two. I'll rewrite this first, and this one too.
X
X times the natural log
X
of
times
e.
So what's the derivative?
So it's first times the derivative is second, so it's x.
See the second? There's no variable. It's just some number. It's just a number. This is like taking the derivative of 5x. Just some number times x. What's the
It's
derivative?
just one. It's just nothing.
Yeah, it's just log base 2 of e.
2 of e times.
That's it.
That's the derivative?
That's the derivative.
You don't need to do anything with the x.
Like the derivative of
Oh, because it's. Oh, okay.
the derivative of 5x is just 5. Derivative of a number times x is just the number.
Oh, okay.
This is just a number, there's no variable, it's just some number. Yes.
Oh, okay, now.
You get 2 like this.
What's that?
How does he get 2 from 10?
Oh,
Sometimes.